All right. So on number 4A, we have A divided by B, or A over B. And we're evaluating for when A is negative 2/3 and when B is 5/9. So we're going to have to substitute those values in for A and B. Okay, in the beginning of the problem, I kind of give it away, but A over B is the same as saying A divided by B, right? So it's kind of my trick when you get so many fractions, like it looks kind of complicated to do negative 2/3 over 5/9. That's a fraction over a fraction. It's complex fractions. It just gets a little confusing. So sometimes it's nice to have that division sign because I know how to divide fractions. I would be doing negative 2/3 divided by 5/9. Well, I know to divide fractions, I keep the first fraction, I change the sign to multiplication, I flip or do the reciprocal of the second fraction, 9/5. So 2/3 times 9/5 would be the same as negative 2/3 divided by 5/9. And then I just go ahead and simplify. Well, here I notice I can actually make this a little easier for myself. 3 goes into 9 3 times, and 3 goes into 3 one time. So now I just have to do negative 2 times 3 is negative 6, and 1 times 5 is 5. So that would be my final answer. If you wrote your answer as a negative 1 and 1/5, that's also fine. Okay? All right. Letter B, or maybe if you did negative 1.2, that's fine too. Okay, sorry. Letter B. We're simplifying this. Well, first we have to evaluate it, and then we're going to have to end up simplifying using order of operations, Gemma. So first, let's go ahead and substitute these values in. 3 is going to be substituted in for J, and 10 is for P. So then my expression will look like 3 times 8 minus 3 to the second power times J is 3 plus J is 3. All over P is 10 minus 6. All right, then we need to simplify. 3 times, and then 8 minus 3 is 5, and 5 is being squared. Remember to do grouping first, times 3 plus 3, all divided by 10 minus 6. Well, you guys are really, the bottom whole denominator is a group, and the whole numerator is a group. So I'm going to go ahead and simplify that bottom. 10 minus 6 I can do is 4. Okay, so now let me go ahead and write out Gemma so I know I'm doing all these steps correctly. We just did the grouping step, part of the grouping step. Now we can do exponents. So 5 squared is 25. So I'm going to go ahead and write that. 3 times 25 times 3 plus 3 all over 4. All right, now we want to simplify all that. We've done the exponents, now we have to do the multiply step. Okay, so here is where I see a big multiplication problem. 3 times 25 times 3. Well, by the commutative property of multiplication, I can just rewrite that as 3 times 3 times 25. Then I would be doing 9 times 25. That's a little bit easier. I can do 9 times 25 plus 3 divided by 4. So 9 times 25 would be 25, 9 times 5 is 45, 9 times 2 is 18, plus 4 is 22, so 225 plus 3 divided by 4, and finally add those together, 228 divided by 4, and then I'd actually have to divide it. So I'd have to say, okay, 4 goes into 228, well, 4 goes into 2 0 times, 4 goes into 22 5 times, 4 times 5 is 20, subtract, and I get 2. Then I'll bring down the 8, and 4 goes into 8 7 times. So 4 goes into 228 7 times. All right, letter C, we're evaluating for when m is negative 3 and when n is 4. If you remember back when we did this assignment, the most common mistake people made is they didn't put parentheses around that negative 3. So you want to make sure you're doing that. So we're going to have 6 plus, substitute for m is negative 3. I'm going to keep that in parentheses, squared, minus 5 times n is 4 cubed minus negative 3 squared. All right. Now I'm going to go ahead and do order of operations, I'll start with the grouping. So I see one group right here at the beginning, 6 plus -3. Okay, well, I can do that. That would be 3. And now all of that squared. Minus 5 times, and then I have another big group here. Well, within that big group, I have -3 squared. Well, that means -3 times -3, which is 9. So I have 4 cubed minus 9. Oh, whoops, I have another exponent there. I don't know why I didn't do that. 4 cubed is 4 times 4 times 4. Well, 4 times 4 is 16, times 4 is 64. All right, let's continue. So I still have another exponent. 3 squared is 9, minus 5 times 64 minus 9. Well, that's inside the grouping. I can go ahead and do 64 minus 9. I know 64 minus 10 is 54, but I'm not subtracting a full 9, so that should leave me with 55. Okay, and then I have to do 5 times 55. I can go ahead and do that on the side. Here we go. Whoopsies, 5 times 5 is 25 plus 2 is 27. There we go, 275. So then I have 9 minus 275. Well, that would just be negative 266. All right. Number 5, estimate the 2 square roots. You're not going to use a calculator, and you're going to make sure you know how to use the estimate fraction. Again, this is where a lot of people made mistakes on their homework because they weren't using the estimate fraction. Okay, so first I need to know, what are the 2 perfect squares that surround 57? What's super close to that? Well, I know 7 times 7 is 49. 8 times 8 is 64. Well, 64 is above it, so that could work. So this is 60, the square root of 64, which is 8, square root of 49, which is 7, and 57 is going to be somewhere in between, maybe around here. Square root of 57. Okay, to do my estimate fraction, well, I know that the square root of 57 is going to be approximately 7 and something. It's going to be a little bit more than 7. Well, I have to figure out what all those tick marks are going to be. So from 49 to 57, I made it, it looks like 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8. From 49 to 57. Out of the total of 49 to 64, one whole would be from one perfect square to the next perfect square. So that would be out of 15, I believe. 64 minus 49. There's another 7 here. So then that would be my estimate fraction, approximately 7 and 8/15. Okay, then I'm supposed to round my answer to the nearest tenths place. So I actually have to divide it out. So I would do, okay, 15 goes into 8, well, 0 times. But now I can do 50 into 80. I know 15 into 80. 15 goes into 60 4 times, so 15 should go into 75 times 5 times. And 5 times 15 is 75, like we just said. We're going to subtract and get 5 remaining. So then we'll do 15 into 50. So that would be 3 times, and 3 times 15 is 45. And we would get 3, and we'd have to bring down a 0. Oopsies. I'm sorry. 50 minus 45 is 5. And then we'd have to bring down a 0, and it's just going to keep repeating. But all I needed to see was this 3 rounds that 5 up to a 5. It keeps it a 5. So the approximate estimate fraction would be 7.5. Okay, letter B. We're doing the radical, the estimate square root of 210. So again, I want to figure out which 2 perfect squares are between 210. Well, I know, let's see, 100 is 10 squared. 12 is 144 squared. 15 is 225 squared. So that sounds like it might be helpful. 225 but that's going to be above it. So 15 is 225. And so then right below that is not 19, oopsies, 14 with the square root of 196. Okay, so 2/10 somewhere in the middle there. Well, let's see. It's 14 places away from 196. This is 14 places away. And from 210 to 225, that's 15 places away. So it's about in the middle. It's about 14 and a half. But let's go ahead and make our estimate fraction. So that would be 14, and it got 14 places out of the total of 29 on the way there. If we're to estimate this, we can go ahead and divide 29 into 15. Well, that doesn't work, so you'd have to do 29 into 150, which would be about 4 times, I believe, so 0.4. And 29 times 4 is, 9 times 4 is 36. And 4 times 2 is 8, 9, 10, 11. So that's 116. Ooh, that might be a little bit too low. Let me try going one higher and going to 5. Well, here's how I would do this one. Instead of doing that multiplication problem, 30 times 5 is 150, but I'm only supposed to multiply by 29. So I just have to take 5 ones away. So 150 minus 5 is 145. So I can subtract that. And I would get 5 remaining, and I'd bring down the 0, and then I do 29 to 50, and that would happen, let's see, 1 time. So that 1 rounds the 5 to a 5. So this would be approximately 14.5.